Hi, this is Abhishek Seturaman, and this is my presentation for EEL6825 pattern recognition. My project is on sentiment analysis for movie reviews using TensorFlow API. Today, we live in a world where user generated data is basically flooding the internet. There's an urgent need to be able to handle all this information and extract knowledge from it. And for any kind of business, it absolutely has to understand its audience, and thus, data analysis is a must. In this project, I'll be looking at a specific case of data analysis, which is sentiment analysis. Sentiment analysis is basically opinion mining. It tries to understand an emotion that is attached to a text. This text could be anything. It could be a product review or a movie review or a tweet. Sentiment analysis basically tries to figure out a polarity, whether it's negative or is it positive. There are two main approaches for this kind of problem, which is knowledge-based approach, and the other is a probabilistic or a statistical approach. The first one, knowledge-based approach. This tries to gather a lot of heavy domain-specific knowledge, first of all, and then tries to apply if-else or inference rules to it to analyze and come to a conclusion. These systems generally provide a why or a how to their reasoning. Thus, this is much more easier for humans to accept and understand. The other is a probabilistic and a statistical approach. These absolutely do not require any knowledge about the domain. They basically rely heavily on statistical and machine learning principles and math. Let's look at two very common models. One is bag of words model or the lexicon based model. Basically, in this approach, you have a sentiment lexicon, which is basically a vocabulary or a dictionary and has a value attached to every one of these words. It could be positive or negative. And all these values, whenever given for a specific sentence, it tries to calculate an overall sentiment by adding or doing some form of addition to figure out the overall sentiment. The other is natural language processing. This basically tries to understand the language itself. This basically, for example, look at this sentence: I eat pizza with a fork. It tries to understand the structure, the grammar of this sentence, and then tries to answer a question. In my project, I'll be using artificial neural networks. Artificial neural network is something that is inspired from biology. Our human brains. Our human brains have a neuron. Our brain cells are basically neurons which have dendrites coming in and axons going out. In a similar way, an artificial neural network has a neuron and it has inputs coming in and outputs going out. Uh, a neuron specifically is responsible for a single computation. It's basically an addition of all these inputs that are coming in. Whenever this addition reaches a threshold value, it fires, and every input is associated to a particular weight. So this is our figure. So we have inputs coming in, and then there is our neuron which tries to calculate the sum, and whenever it reaches the threshold function, it is triggered. And, a single neuron is useful, but whenever we need to be solving complex problems, we need different layers. We have the input layer, the output layer, and a middle hidden layer. Hidden layer can consist of more than one layers, obviously. The deeper it goes, the more complex computations it can do. In my project, I'll be using TensorFlow API. TensorFlow API was built by Google Brains, and this is a deep learning library. It is very easy to use for any developer and any student out there. In my project, I'll be trying to implement recurrent neural networks also. Basically, recurrent neural networks is for sequential incoming data. That is, if for example, you are trying to predict a next word of the sentence, then one needs to understand all the words that came before it to actually come to a conclusion or to arrive at a guess. This provides for a memory for the neural network. Looking at this figure on the left side, which is for recurrent neural network, we can see that a computation done previously is applied to the next computation itself on those nodes. Like we have those inputs, outputs coming back again as inputs for the next computation. I'll also be trying to implement short-term memory for my project. This is a special kind of neural network which allows the network to retain memory over a longer period, which is why the name long short-term memory. Um, so this is helpful whenever we have the issue of the vanishing gradient problem. In our case for sentiment analysis, this is very useful. So let's look at some program. So these are my attempts. I have about 8 attempts. So my first attempt was to give a very basic neural network. Before that, let's try to understand what I've done here for the pre-processing. TF-learn is a library that is basically a high-level abstraction on TensorFlow. In in this line, I have tried to capture reviews from IMDb directly, and then I have divided it into training set and the test set. And every training set has a specific portion which is used for validation purposes. Okay. Uh, for all these inputs, we try to vectorize them. When we try to vectorize them, we use paired sequences. So, and the next part is for these outputs, we use two categorical function. Two categorical is basically useful when we need to understand the output. Like here we have two classes. My sentiment analysis does binary classification. Hence, it uses nb underscore classes equal to 2. So let's come to the basic neural network model. So we have an input layer here and a hidden layer and an output layer. So this hidden layer is basically a fully connected one. It is connected to every node on the other layer. So as we can see, uh, a previous layer's input is fed into the next one, and so on. The optimizer that I've used in my project is simply Adam, and the learning rate for this is 0.0001. So in this, as we can see, it has 2 units, which means it classifies it as 1 or 0 as per our binary classifier. Okay, so this was my first attempt. This was a very basic idea. So this came up, I've already trained this, and this came up to around a test accuracy of 51.12%. And in attempt 2.0, I've tried to implement recurrent neural network, but this is a very simple one. Uh, Before this simple RNN, I have used an embedding layer. What embedding layer does is it converts 10,000 input dimension into a 256 output dimension, and this is fed into the simple RNN. This has a dropout rate of 0.8, and the activation function that I've used here is softmax. In the first attempt, I've probably used sigmoid, but here I've used softmax. And we look at the data for all these test cases separately on a chart. For now, let's just look at the neural network that I've made this for this second attempt. And for the third attempt is where I bring in long short-term memory. So this is very similar to what we've seen in 2.0. And in this, what I've done is I've directly specified that I need to use a tflearn.lstm, and this similarly has an embedding layer from previous layer, and this converts it from 10,000 to 256. So let's look at the test accuracy of each of these cases. I have around 8 of them. So let's go back to my presentation full screen. So yeah, So, so as we can see, we I have done 8 different attempts, and the first one was simply fully connected using an activation function of sigmoid, and it turned out to have an accuracy of 49.435. And within these attempts, I have simply extended it by using another fully connected layer and still using the same activation function. For the third attempt, I have used softmax activation over sigmoid, and this has turned out to be 50.44. There's not much difference here. Uh, so for my attempt 2.0, I have used an embedding layer which gives out an output dimension of 256 and used a simple RNN, and I've again used a softmax. And for 2.1, I have used output dimension 128 and simple RNN. This basically does more compression, and the activation function used is softmax again. We sense a little drop. It's not much, but it's still there. And for 2.2, I have again retained 256 output dimension, simple RNN, and I have also used another fully connected layer. Uh, for this, I have got a higher value of accuracy, which is 75.36. But the, the spotlight in this project has to be LSTM, which gave me 81.28% accuracy. Using fully connected hasn't given me much difference, so this would be my highlight here. Okay, so this is the graph here. As we can see that for all the earlier attempts, when we didn't have a recurrent neural network, it was really substandard, and when we've used RNN and when we view LSTM, we have reached 81% accuracy. So thank you for Professor for giving me this opportunity to do such a project. I hope it was satisfactory. Thank you.